In this class, we are going to discuss series RLC circuit excited by an AC supply. Series RL, comma, RC and RLC circuits excited by an AC supply. Excited by an AC supply. Remember, whenever we are going to discuss about the series circuits, remember a few points. First, the series combination. We need to draw the phasor diagram and voltage triangle of that series combination. Phasor diagram and voltage triangle. Phasor diagram and voltage triangle. And second, calculate impedance of the series circuit. Impedance. Sorry. Calculate impedance and draw the impedance triangle. Impedance triangle. This is the second step. And third, calculate current and draw the waveforms. Calculate current and draw the waveforms. Next, calculate instantaneous power. Instantaneous power and average power. Average power. These are the four steps we are going to follow for series RL, RC and RLC circuit excited by an AC supply. Is it clear? First, we need to draw the phasor diagram and voltage triangle. Then we need to calculate impedance and draw the impedance triangle. From the impedance triangle, we need to calculate power factor and phase angle. Then calculate currents and draw the waveforms. Last one, calculate instantaneous power and average power. And these are the 4 points we are going to discuss for all these series combination RL, RC and RLC. Is it clear? Yeah. First we are going to discuss about series RL circuit. First we are going to discuss about series RL circuit. Yeah. First one, series RL circuit excited by an AC supply. Excited by an AC supply. Series RL circuit excited by an AC supply. Is it clear? Yeah. For that, first we need to draw the circuit diagram. Series RL circuit. I am taking one resistor R and it is connected in series with an inductor L, and these two series combination is connected by AC source. Is connected by AC source. Is it clear? Yeah. And the resistor is R, inductance is L, and the source voltage V of t is equal to Vm sin omega t, and the current flowing through the circuit is I of t, instantaneous value of current. When current Therefore, the current flowing to the resistor, we are calling it as IR. The current flowing to the inductor is calling as IL. When IR current is flowing through the resistor, then voltage drop across the resistor. Voltage drop is occurring across the resistor. That is voltage drop. We are denoting by VR, and voltage drop across the inductor when current IL is flowing through, then that is VL. Okay, and this is the series combination of circuit. And since it is a series circuit, since it is a series circuit, we know that since it is a series circuit, series circuit, series circuit, therefore I of t is equal to IR is equal to IL. I of t is equal to IR is equal to IL, because in series current flowing through all circuit elements is same. Remember this point, current flowing through all elements is same. Then from the circuit, let V of t is equal to instantaneous voltage, instantaneous applied voltage, instantaneous applied voltage, and I of t is equal to instantaneous current, instantaneous current flowing through the circuit, and VR is equal to voltage, voltage drop across resistor, voltage drop across resistor, that is equal to, that is equal to IR into R, that is equal to IR into R. And we know that in pure resistor voltage and current are in phase, therefore VR is at an angle 0. Therefore, if current flowing through the circuit is same, then we are to draw the phasor diagram. We are taking current as a reference phasor. Then I is at an angle 0, because current is taken as a reference phasor. Reference phasor phase angle is 0. Then I is at an angle 0. Next, VL, voltage drop across inductor, voltage drop across inductor, that is equal to IL into JXL, where JXL is the impedance of the circuit, impedance of inductor, impedance of inductor, that is equal to VL at an angle, VL at an angle 90. With respect to current, voltage drop across inductor is leading current by 90 degrees. This is the main. With respect to current, with respect to this current, voltage drop across inductor is leading. Okay, then these are the things from the circuit. Then first, next, we are going to draw the phasor diagram and voltage triangle. Phasor diagram and voltage triangle. Phasor diagram and voltage triangle. Voltage triangle. Yeah, remember, to draw the phasor diagram for any series circuit, I already told current flowing this series circuit is same. Therefore, current is taken as a reference phasor and with angle 0. Therefore, current is drawing in x-axis with angle 0. Current is drawing in x-axis with angle 0. This is I at an angle 0. Because current is same, we are taking current as a reference phasor. Then we need to draw the voltage drop across resistor in the phasor diagram. And we know that we are in pure resistor voltage and current are in phase. Therefore, VR is in phase with the current. Draw VR in phase with current. That is, this is VR at an angle 0. Next, we need to represent voltage drop across inductor in the phasor diagram. Okay. And we know that in pure inductor, voltage is leading current by 90 degrees. Voltage is leading current by 90 degrees. Therefore, VL is leading current by 90 degrees. Okay. VL is leading current by 90 degrees. And to get the total applied voltage, okay, and simple by applying KVL, V is equal to VR plus VL, then we are showing with vector representation. By adding VR and VL, then we are getting V supply voltage, applied voltage or supply voltage. Then simple, we are adding these two. This is our voltage phasor diagram or vector diagram, and this is the phasor diagram. Then the angle between applied voltage and current is not exactly 90 degrees, and this is angle, suppose it is angle phi. It is angle phi. And this is the phasor diagram of series RL circuit. Remember, once again, I am taking current as a reference phasor, drawing in x-axis with phase angle 0. Then VR is the voltage drop across resistor. Voltage drop across resistor. In pure resistor, current and voltage are in phase. That's why VR is in phase with the I. Next, VL is the voltage drop across inductor. We know that in pure inductor, voltage is leading current by 90 degrees. Therefore, this is the phasor diagram. This is the representation of VL. And then when we are adding VR plus VL, then we are getting total supply voltage. And this is the phasor diagram. Is it clear? In this figure, phasor diagram. Phasor diagram. Next, draw the voltage triangle. Voltage triangle. Voltage triangle means just we are considering only voltages in the phasor diagram. Only voltages in the phasor diagram. This is VR. This is VL. And this is supply voltage V. And the angle is phi. This is voltage triangle. Voltage triangle. Voltage triangle. And we know that VR is nothing but IR. VR is equal to IR and VL is equal to IXL and V is equal to IZ. V is equal to IZ. And what is the next point after completing phasor diagram and voltage triangle? Next, we need to draw the, we need to calculate impedance triangle. We need to calculate impedance triangle. Second point. Is this clear? Yeah. Calculate impedance and impedance triangle. Impedance Z. Okay. And from the phasor diagram, we are considering that, or from voltage triangle. Otherwise, from the voltage triangle, or by applying KVL to the circuit. By applying KVL to the circuit. By apply KVL. By applying KVL here. By applying KVL, what we are writing? V is equal to VR plus VL. V is equal to VR plus VL, or also from we are considering from the voltage triangle. No problem. V is equal to VR plus VL, and we know that VR is nothing but voltage drop across resistor, that is I into R, and VL is nothing but voltage drop across inductor, that is JIXL, JIXL, and then take I common, R plus JXL, then V is nothing but I into Z, just like IR, and then II gets cancelled, I, I cancel. Therefore, impedance Z is equal to R plus JXL. Impedance Z is equal to R plus JXL. This formula, this is the impedance of series RL circuit. Remember, this is the impedance of series RL circuit. Impedance of series RL circuit measured in ohms. Okay, and then next we need to draw the impedance triangle. We need to draw the impedance triangle. Impedance triangle. And from the voltage triangle, from the voltage triangle, we are divide this voltage triangle by current. And divide this voltage triangle by current, then we are getting impedance triangle. Divide this voltage triangle by current, we are getting impedance triangle. Remember, divide voltage angle by current. Divide voltage triangle by current, then we are getting impedance triangle. And this is R, this is XL, this is Z. And the angle is phi. And the angle is phi. Okay, now from the impedance triangle, cos power factor, cos phi is equal to, what is the cos phi value? R by Z. R by Z. And we need to calculate phase angle. Phi is equal to tan inverse of imaginary by real part. What is the imaginary part? It is tan inverse of, imaginary part is XL, real part is R. And this is the phase angle. Phi is equal to tan inverse of XL by R. Phi is equal to tan inverse of XL by R. And this is the second part. We are calculating impedance, that Z is equal to R plus JXL. Then we are drawing impedance triangle. From the impedance triangle, we are writing the formula for power factor. Cos phi is equal to R by Z, and phase angle phi is equal to tan inverse of XL by R. This is the second part. Okay. Next, we need to calculate the current. We need to calculate the current. Yeah. Next, we need to calculate current I of t. Current I of t, and also draw the waveforms. Okay. And what is the formula to calculate current? Actually, I is equal to V by R, right? And then here I is equal to V by Z. I is equal to V by Z. Okay. And then we know that voltage is at an angle 0, Z is at an angle phi. Okay. Then V by mod Z actually it is, okay, mod Z, and then it is 0 minus 5. V by mod Z at an angle minus 5. Okay. I am writing V by mod Z. I am writing capital I at an angle minus 5. Okay. This is Im otherwise. Therefore, I of t is equal to Im sine of omega t minus 5 amperes. This is the instantaneous current flowing through the RL series circuit. Instantaneous current flowing through series RL circuit. Right? Then we need to draw the waveforms. Waveform of series RL circuit. To draw the waveforms, we know current equation instant and voltage equation. Instantaneous current equation and instantaneous voltage equation. What is the instantaneous voltage equation? V of t is equal to Vm sine omega t minus 0 otherwise, and I of t is equal to, just now we calculated, Im sine of omega t minus 5. Yeah, and here observe, here the voltage angle is 0 and current angle is minus 5. Means current is starting after the voltage. First we need to draw the voltage waveform. First we need to draw the voltage waveform. My voltage, instantaneous voltage, right? Then draw the current waveform. Draw the current waveform. And current is, see here, voltage phase is 0, but current is starting after the voltage at an angle phi. Suppose this is the angle of phi. This is my current equation. This is phi. Okay, now, therefore the angle between voltage current and this is 0. Therefore the phase difference between these two, phase difference, note here, right? Note, phase difference. To calculate phase difference, reference minus second one. What is the reference phase and phasor? Voltage phase is 0 and minus 5. And therefore we are getting phase angle is, current phase is minus 5. Yeah, what is the meaning of minus 5 phase angle? And current is lagging voltage by some angle phi. Current is lagging voltage by some angle. Is this clear? Voltage is lagging, sorry, current is lagging voltage by some angle phi. Is this clear? Yeah. Next, we need to calculate instantaneous power. We need to calculate instantaneous power and average power. Last, instantaneous power and average power. Instantaneous power and average power. Yeah. First, we are calculating instantaneous power. First, we are calculating instantaneous power. Then V of t is equal to V of t into I of t. Then V of t, we know that voltage equation Vm sin omega t, and Im current is Im sin of omega t minus phi. Okay, take Vm Im constant. Vm Im, I am writing this is sin omega t into sin of omega t minus phi. Sin of omega t minus phi. Therefore, we know that sin A and sin B is equal to 1 by 2 cos of A minus B minus cos of A plus B. Remember this formula, sin A sin B is equal to 1 by 2 cos A minus B minus cos A plus B. Therefore, here A is nothing but omega t, B is nothing but omega t minus phi. Remember. Therefore, Vm Im 1 by 2 cos of A minus B means A means omega t minus B means omega t minus phi. Omega t minus phi and minus cos of A means omega t plus B means omega t minus phi. Okay. Then Vm Im into 1 by 2. Here, see, omega t minus omega t gets cancelled. These two are cancelled. Then minus omega t minus phi and minus phi. It becomes plus. And it is cos phi, okay, minus cos of 2 omega t minus phi. And this is the value of instantaneous power. This is the value of instantaneous power. Okay, P of t is equal to Vm Im into 1 by 2 cos phi. Otherwise, write Vm Im by 2 cos phi minus Vm Im by 2 cos of 2 omega t minus phi. This is P of t. Instantaneous power is equal to E Im by t cos phi minus Vm Im by 2 cos of 2 omega t minus phi. Okay. Next, we need to calculate average power. Okay. We need to calculate average power. Average. Right. And we know that the average power consumed in the circuit, the average power consumed in the circuit over one complete cycle over one complete cycle is given by zero, right? Therefore, the average of Vm Im by 2 cos phi minus average of Vm Im by 2 cos 2 omega t minus phi. Okay, na? And this total term, complete cycle, average of complete cycle is zero, right? Therefore, this part becomes zero. Therefore, P is equal to only Vm Im by 2 cos phi. Vm Im by 2 cos phi. Therefore, I am writing this is Vm by root 2 and Im by root 2 into cos phi. We know that Vm by root 2 is nothing but Vrms, Im by root is nothing but Irms. Therefore, it is Vrms into Irms to cos phi. Vrms into Irms into cos phi. Therefore, we are writing Pi cos phi. We know that RMS values we are denoted by capital letters. Is it clear? Capital letters. This is the average power consumed by the circuit when it is series RL circuit excited by AC supply. Series RL circuit excited by AC supply. Here, what do you mean by cos phi actually here? What do you mean by cos phi? Cos phi is nothing but power factor, where cos phi is called power factor. Phi is called power factor of the circuit. Yeah. What is the power factor value? Cos phi is equal to R by Z. This is from impedance triangle, or VR by V. This is from voltage triangle. This is from impedance triangle. Impedance triangle. This is from voltage triangle. Is this clear? Yeah, this is about series RL circuit is excited by AC supply. Series RL circuit is excited by AC supply. Thank you.